The binomial distribution is one of the most important discrete probability distributions. It's used a lot in math and science and finance. In order to use the binomial distribution, we have to consider a special type of experiment known as a Bernoulli trial. A Bernoulli trial is experiments in which there are only two possible outcomes. Generally, we refer to this as a success or a failure. For example, a coin toss experiment, we may only be interested in obtaining heads, and thus consider heads to be a success and tails to be a failure. In a Bernoulli trial, the probability of success for each trial is always the same. That's an assumption. This means that we have sampling with replacement. So if you're removing items from your sample that significantly affects background success rate, then you can't use the binomial distribution. The outcomes of different trials are independent, so they don't affect one another. Bernoulli trials are frequently encountered in engineering when considering if products meet specifications, for example, quality control. The formula for the binomial distribution is given here. Again, it's a probability density function, meaning that the sum over all possibilities equals 1. The f of x is always going to be between 0 and 1. This first term here, n over x in parentheses, that's just the same as n choose x. And we all know that that's equal to n factorial divided by n minus x factorial over x factorial. We multiply by p, that's the probability of success, raised to the x. X in here is going to be, you're trying to calculate the probability of getting exactly x successes. And then we multiply by 1 minus p raised to the n minus x. So again, here n is the number of trials, x is the number of successes that you're interested in, and this determines the number of exact successes. So you can't use at most or at least, you have to adapt this. N over x, that's the number of ways x successes can be selected from n total experiments. P is the probability of success. It turns out for the binomial distribution, the mean is just the number of trials times the probability of success, and the variance is np times 1 minus p. Let's work through an example here. I've got 5 parts to this example. The weather forecast is calling for a 20% chance of rain for each of the next 5 days. So looking at this, we're going to call a success is actually going to be rain. The probability of success is going to be 0.2. The number of trials that we have 5 trials. Now this is a Bernoulli trial because we have a certain probability of success, 20%, and a certain probability of failure. We also have a fixed number of trials, and we also know that they are independent of one another. The first part, what is the mean, the expected value for the number of days that it will rain? Well, for the binomial distribution, the mean is given by n times p. And you might just look at this without using this formula, and you might say, in 5 days, 20% chance of rain each day, it's probably going to be one of the next 5 days. And that's exactly what the mean does. If we take 5 times 0.2, we get 1. So 1 day is the expected value for the number of days that it's going to rain. The second part, what is the probability that it will rain none of the days? So that means x equals 0. We can write this, f of x equals 5, choose 0, times the probability of success, 0.2, to the x, so that's going to be 0, times 1 minus p, which is 0.8, raised to the n minus x. In this case, that's 5 minus 0, and that's just 5. And when we do our calculation, we end up with the probability of 0 is equal to about 0.328. So that means that the probability that it will rain none of the next 5 days is 0.328. Part C, what is the probability that it's going to rain all of the days? So that means x equals 5. We can put that in, f of 5. 5 choose 5, 0.2 to the 5th times 0.8 to the 0. Both of these are 1, by the way. And we end up with 0.2 to the 5th, which is 0.0032. So a very slim chance that it's going to rain all of the days. What is the probability that it's going to rain at most 2 of the days? So you should be careful and aware of these phrases at most and at least. At most means it's going to rain 0 or 1, right? At most, 0 or 1 days. This probability, at most 1 day, is really the sum of the probability that it's going to rain none of the days plus the probability that it's going to rain one of the days. And we can plug both of those into the binomial distribution. And when you calculate this, you would get 0.737. Now let me mention to you that sometimes it's easier to use the cumulative distribution, and I'll show you how we can use this in Excel. As you recall, this, the sum of those, is also equal to capital F of 1, or the cumulative distribution function. This we can get from summing the previous terms up to and including 1, or we can also get from Excel if you are able to use Microsoft Excel. And so I'll show you that now. First, I'm just going to show you how to solve the non-cumulative distribution function. So in this example, we have 5 trials, 5 days. Each day we have 20%. I'm going to go ahead and name these. I can select those and go to Formulas tab, Create from Selection. And now B1 is named little n, B2 is named little p. There's a function built into Excel called the binom.dist function. The first argument is the number of successes. So this is your unknown or your independent variable. So if I want to calculate the probability of getting exactly 0 successes, I can reference A5. The number of trials would be n. The probability of success, that's the next argument there to this function, is p. And then the last argument is whether or not you want it to be cumulative or non-cumulative. And so what I'm going to do first is type in a false. So I'm just looking at the non-cumulative. This is exactly 0 successes. And I press enter and we get 0.328, which is what we got doing this by hand using the formula for the binomial distribution. And now I can drag this down. So that's the non-cumulative distribution. Now remember, what we're trying to find is the probability it will rain at most 0 of the days. So that's little f of 0 plus little f of 1. I can do that in Excel by just summing f of 1 and f of 0. And we get there's a 73.7% chance. And that's what we got calculating that by hand. You can also use the binom.dist function using true for the cumulative argument at the very end. And that represents capital F. So I'm going to put in 0 or A5 there. We have n trials. The probability of success is p. But I'm going to type in true here, meaning it's cumulative. I press enter. And if I drag this down, this is telling me the cumulative probabilities up to and including each of these x values over here. And so at most, I could also just reference capital F of 1, and that's 0.737. The last part of this problem, my example, is what's the probability that it's going to rain at least 3 of the days? At least meaning f of 3 plus f of 4 plus f of 5. So each of those. Now this probability we can determine as 1 minus up to and including 2. So this is the same thing, 3 or more, 3, 4, 5, that's equal to 1 minus f of 0 plus f of 1 plus f of 2. And that is the same thing, that's the cumulative function when x equals 2. When I look on Excel, I can get the cumulative f of 2, capital F of 2, is equal to 0.942. So we can just subtract 0.942 from 1, and that means the probability of it raining at least 3 days is going to be about 5.8%. Hopefully you learned quite a bit about the binomial distribution, Bernoulli trials, and how to use the binomial distribution function in Excel. Thanks for watching.